I haven't been recording. Okay, so starting the recording just a little bit late. What I did is go over basically some more synthetic division. Zaith, did that answer your question? I mean, you wanted an example. I could do something a little bit more involved if you like. But if that's all you needed, then I'll move on. Did you want one more of those? Okay, that's good. Then I think it was Zaire. Yes, you mentioned complex zeros. Give me a little bit more information. Do you need to know how to find the complex zeros, or what? And I'm at the same time, I'm looking in my book to see what they're doing with these. Okay, I'll get back to complex zeros in a minute. Say yours is, let's look at what we just looked at. We had x cubed, well, f of x equals x cubed plus 6x squared plus 11x plus 6. Okay, we'll look at the problem that you just gave me if that's the one you're having trouble with. If we need to, we can come back to that one. X to the third plus 9x squared plus 25x plus 25. Okay, not written really well, but we can figure out what that says. Okay, this is f of x. And if you look at that, there are no sign changes. That means there are no positive solutions. Okay, because you count the sign changes to tell if the to find how many positive solutions there are. Well, there are no sign changes, so there are no positive solutions. To find the negative solutions, you look at f of negative x, which means what do you have if you replace x with a negative x? Well, a negative x cubed is negative. A negative x squared is positive, so that sign's not going to change. If x is negative, 25x is negative 25x. Now, if you count the sign changes, there's 1, 2, 3 sign changes. And by the way, the problem I did was just like this because we started out, there were no sign changes. If there's 3 sign changes, that means there are 3 negative solutions. So Zayth, I kind of think maybe were you correcting what I wrote here? I actually wrote a 3 and it looked more like a 2 when I first wrote it. But you're right, there are 3. So when we look at our p's, p is plus or minus 1 and plus or minus 5 and plus or minus 25. Q is plus or minus 1. Zayth, you went from a minus to a plus, that's 1 sign change. Then you went from a plus to a minus, that's 2 sign changes. Then you went from a minus back to a plus, that is 3 sign changes. Okay, so if there are 3 sign changes, and you do have to count the first one, up here in the original, there was no sign in front of the x cubed. You have to remember that that's a plus when you're counting sign changes. Okay, so these are possible solutions. However, when doing this, okay, I think you're talking about in the f of negative x, how do we know which to change? Well, because a negative number to an odd power is negative. A negative number to an even power is positive. Negative 1 squared is a positive 1, but negative 1 to the third is negative 1. So basically, I went through and sort of told you how I was changing it. But basically, if it has an odd power, the sign changes. So x cubed is a negative, and x is a negative. And that's how you know which ones are going to change. And it's not always going to be every other sign is changed because it depends on what you had to begin with. We happen to have all positives to begin with. So now when you do the synthetic division, there's no reason to put in any positive numbers because you know there are no positives. So start with, and now when you do this, you might want to put the f of negative x off to the side or something because you don't want to get confused. It's f of x we're using the coefficient for. So we have 1, 9, 25, and 25. And I sort of already looked at this in my head, and I don't think negative 1 is going to work. So let's start with negative 5. Bring that down, that's 1. 1 times negative 5 is negative 5. That gives me 4. 4 times negative 5 is negative 20. Bring that down, it gives me 5. And 5 times negative 5 is negative 25. which is 0. Now, again, you could use synthetic division again if you wanted to. Let's go ahead and do it just because I want to show you something. We know there's going to be no positive. You could try -5 again. It could be a double root. And when you do that, that's 1. That gives me -5, which is a -1, which gives me 5, which gives me 10. Again, doing it quickly in my head, I thought that was going to work. It didn't. I'm just double checking to make sure. But I think it should have. Because what you're left with here is x squared plus 4x. No, it won't work. Plus 5. If we were to factor that, we'll put an x here and an x here. This has to be a plus, and this has to be a plus. But we need a product of 5 that has a sum of 4. The only thing that gives me a product of 5 is 5 and 1, and we're going to get a product of 4. So that can't be factored. Not only that, it's going to have any rational solutions. Because they can't be positive. The only other things we have to try is 1 and -25. If you try those, they're not going to work. If they did work, then we would be able to figure this. And we can't. So go to the quadratic formula. And you have x equals a is 1, b is 4, and c is 5. So -b gives you -4 plus or minus the square root. B squared is 16 minus 4 times 1 times 5 is 20 over 2a, which is 2. And I'm running out of room. I'm going to write as small as I can. Equals -4 plus or minus, and 16 minus 20 is 4. I'm sorry, -4. The square root of -4 is 2i. Because it's negative, the I goes in there, over 2. Both of those terms are divisible by 2, so you get a -1 plus or minus, I'm sorry, -2. 4 divided by 2 is 2. So it's a -2 plus or minus I. So I'm going to change colors so you can see where I'm writing it. The solutions to this are, this didn't work, that didn't work. We have this and that. So the 3 solutions would be x equals -5, -2 plus I, and -2 minus I. Okay, I know some of you are beyond this point in the book, but you weren't asking any other questions either. And this is a real good thing to see examples of. Zaith and Zaire, you were both asking questions on this. And I think you both were in classes that started later than the others. So do you have any further questions on this? Now's the time to ask. Well, you're welcome very much, and I'm glad it helped because as I do this, sometimes I feel like I'm talking to myself, probably because I can't see any students out there. And sometimes I'm just going over what I think you need, and I'm not really sure if it helps any of you. That's a good thing. That included some imaginary zeros. I don't remember which one of you asked. Zaire. I went back and looked. You asked for help with complex zeros. Was that mainly what you needed, or do you need more than that? They do get a little more difficult than that. Okay, that's good. Let's go back to that last problem just a second. And you had it written down here. X to the third plus 9x squared plus, come on, right, plus 25x plus 25. And we came up with -5 was one solution, but the other solutions, it was a 2 plus or minus I. Was it a -2 in front? I forgot. Okay, thank you. Because what I'm going to show you, if you knew that that was a solution, it's a little more difficult, and I really believe that starting with the 5 and using the quadratic formula probably was the way to go with that problem. But if you were told that, let's just say you were told that -2 plus I was one of the solutions, you can use synthetic division as long as all of the coefficients are rational, which means they can't have a square root or an I in them. So if you use 1, 9, 25, and 25, you can give me that example, but let's do this first, and I think it might at least help you see that you can do these. It's a little more difficult because you're multiplying by an imaginary number. You bring down the 1. This gives you -2I plus I. And if you add 9 to that, you're -2I plus 10. Now, just to show you, we've got negative. Now, I said 10. It wrote 9. That was my fault. -2I plus 10. And we're multiplying that by negative 2 plus I. And I did this wrong. Already I made a mistake. 1 times negative 2 plus I is negative 2 plus I. Which gives you 7 plus I, which is what this should be. I did say this is a little more difficult. And basically FOIL that, you're going to get minus 14 plus 7I minus 2I. Then you're going to get plus I squared, but plus I squared is a minus 1. So that gives you minus 15 plus 5I. So yeah, minus 15 plus 5I. And if you notice, I didn't give myself enough room here. But the 25 and the minus 15 give you 10 plus 5I. So you've got 10 plus 5I that you're going to multiply by negative 2 plus I. And that gives you negative 20 plus 10I. And then the 5I times the negative 2 gives you minus 10I. And 5I times I is 5I squared, or minus 5. Well, the I terms subtract out and you get minus 25. So that gives me a minus 25 that goes up here, and you add those together and you get 0. Now, you now have imaginary numbers as coefficients. However, you also know that minus 2 minus I is going to be a solution. Okay, but I just wanted to show you that you can do this with imaginary numbers, but it does become a bit tricky. You have to make sure that you do the multiplications correctly. Okay, Zaith, what was the problem that you completely gave up on? While I'm waiting for him to get it again, which is not with some of these, grade your quizzes from last week. Most of you showed me that you are doing very well with factoring. So hopefully you did those all on your own and they came out well. Okay, we have 6x cubed minus 25x squared Meanwhile, Zaith, what did you need to do with this? Minus 24x minus 5. Just find all solutions. Okay. Your p's are plus or minus 1 and plus or minus 5. Your q's are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Also, looking at positive and negatives. Positive solutions. Remember, this 6 is a plus. So there's one sign change. That's not a sign change, and that's not a sign change. So there is one positive solution. Okay? Because we went from a positive to a negative, and then the rest are all negative. Now, just to save space, because I only get one little whiteboard, the f of negative x cubed, the sign changes, so that's going to be a minus. X squared is also a minus. The x to the fourth is going to be a positive. I'm sorry, I think I said x to the fourth. It's 24x, but that's become positive. And then the negative 5, of course, is going to stay negative. I just lost my screen. There it is. That's going to stay negative. So here, negative, negative, positive, that's one sign change. And then it goes to negative. That's two sign changes. So for the negative, there are going to be two negative solutions. Okay. I might go ahead and try the negatives first, just because there's more of them. So we have 6 negative 25, negative 24, and negative 5. Remember, the p's go on top and the q's go on the bottom. So the only things that we have that wouldn't be fractions would be plus or minus 1 and plus or minus 5. So let's start with a minus 5. Bring down the 6. 6 times negative 5 is negative 30. That gives me a negative 55 times the negative 5 is going to be really big. I'm going to subtract 24 from it. I don't think that's going to work. So let's go back and hope I don't erase the whole thing here. Since we tried a negative 5, it didn't work. Let's go ahead and try 5. And then we'll go back to our plus or minus 1. So we'll change it to a plus 5. That gives me 6. That gives me a positive 30, which makes that 5. And 5 times 5 is 25, which gives me 1, and 1 times 5, that gives me 0. So that worked. And that is my one positive solution, which means my other solutions have to be negative. And it looks like maybe -1 is going to work. Again, you could go ahead and factor that. But if we do this, because maybe we're not too good at factoring, that gives me -6 there, which is -1 times -1. Oh, I thought that was going to work. I did do everything correctly there, didn't I? Positive 5. -6. That's a -1. Okay, that didn't work, which means we have fractions. So I really don't like working with fractions. I'm sure those of you that are with me, most of you don't like fractions either. So we have 6x squared plus 5x plus 1 that we want to factor. I put a 6x here and a 6x here. That says both signs are positives. I need a product of 6 that gives me a sum of 5. So that would be 2 and 3. That's a 2 there and a 3 there. Okay, I can divide a 2 out of that and a 3 out of that. And that gives me the 6 that I have to divide out. And this gives me 3x plus 1. And this gives me 2x plus 1. If I set both of those equal to 0, I get x equals -1/3 and x equals -1/2. So those are my two negative solutions. And my positive solution, I should have written it right inside, but I didn't, was 5. That's how knowing how many positive and negative solutions is helpful. Now, I said there's two negatives, so I'm going to start with negatives. And I started with -5, and it didn't work. But because of the size of those numbers and what they were, I chose to then choose 5. And it worked, and I didn't have to worry about any fractions then. You can do fractions with synthetic division. Let's look here. I'm going to erase what I did. And because 1/3 is probably harder to work with than 1/2, I'm going to go ahead. Well, let's erase this. And put in -1/3. Now, I already know that it's a solution, but I'm just showing you that you can use fractions with a synthetic division. You bring down the 6. 6 times 1/3 is 2, or 1/3 of 6 is 2. The 3 divides out, leaves you with 2. So that's negative. So we have a -2. Combine those, I get a 3. 1/3 of 3, or 3 divided by 3, is 1, but it's negative. And that gives you 0. And what you're left with then here is 6x plus 3 equals 0. 6x equals negative 3. So x would equal negative 3 over 6, which is the same as negative 1/2. So there are your 3. And if you wanted to do synthetic division with a linear equation, you could. I didn't even think about that when I was doing it, because once you have a linear equation, you should be able to solve it easily enough. But just to show you, and the problem here is I know what the solutions are, so it's easy for me to do the synthetic division. If you don't know what they are, solving the linear equation should be easier for you. Okay, got that erased. If I go back and use negative 1/2, bring down the 6. 1/2 times 6, half of 6 is 3, but it's negative. That's a negative 3, negative 3. And that gives you 0. So there are the 3 solutions. Okay, any questions on that? Okay. Then let's go to exponential and logarithmic equations. If I skim over something and you need a little bit more information on it or a better explanation, simply let me know. But in general, an exponential function is of the form b to the x. Oh, shoot. Well, if I'm defining a function, I should have started with a f of x. I didn't leave myself room to squeeze it in. It would have been a tight squeeze. F of x equals b to the x, where b is greater than 0. B can be any number, but it needs to be greater than 0. Because if you have a negative base and you raise it to a power, it's going to be jumping from positive to negative, and it really doesn't make any sense. A function that does that. X can be positive or negative. The exponential function it doesn't matter what b is. Anything to the 0 power is 1. So no matter what your base is, it's going to go through 0, 1. The x, if it's negative, b to the negative x is the same as 1 over b to the x. Well, think of an easy problem and let x be 2. I'm sorry, b be 2. Well, 1 over 2 to the first is 1/2. 1 over 2 squared is 1/4. 1 over 2 to the fifth is 1/32. So the number is getting smaller and smaller if x is negative. So it's approaching the x-axis, and mine even touched it. But if you zoomed in, you would notice that it doesn't really touch it. It's just very small. 1 over anything can never be 0. And as long as b is a positive number, it cannot be negative. So it has a vertical asymptote where y is 0. And now, if you think about it, again, if using 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So even though we're only increasing 1 on the x-axis, it's doubling basically on the y-axis. So, not drawing real straight this morning, but that's what an exponential function is going to look like. And any exponential function is going to look like that. Now, if f of x and x is less than 0, that means it's negative. Well, that means b to the x is going to be this, because we put the stipulation that x is less than 0. So if x is less than 0, from this point, you're still going to have the point 0, 1, because it doesn't matter. Well, let's say I guess we could say x is less than or equal to 0. The function is going to look like this. I'll call you back later. Sorry about that. I had a call and I answered it by mistake. Okay, that's what it looks like if x is negative. So if you had f of x equals, say, b to the negative 3. Okay, b to the negative 3 I'm sorry. Right? No, that's right. When x is negative 3, that's not what that says. Never mind. That's But anyway, if x is negative, it's going to do the opposite. Now, when you have looked at inverse functions, I'm just going to erase this whole screen for now, and we'll sort of combine that with what we're going to do now later. Now, some of you, either in high school or a course that you've already taken at Forsyth Tech, you may have seen logarithms a little bit, but it's probably fairly new to you, and even if you've seen them before, it's probably something that didn't make a whole lot of sense, or you weren't really sure what they were. But we do use logarithms. Logarithms help us solve an equation that has an exponent, that has the variable in its exponent. So logarithmic functions are in the form log base b of x. Now, there is a lot done with changing logarithms to exponents and exponents to logarithms. Okay, so in the previous screen, we had basically, I was going to write f of x. Let's make it y. Let's leave it as y. Y equals log base b of x is the same thing as saying b to the y equals x. Now, it's really, pay attention to what I'm going to tell you, and it's not difficult to change from an exponential, which is the b to the y equals x, to a logarithm, which is log base b of x equals y. Start at the base. If you have a logarithm, start at the base, go across the equal sign, and then come back, which means changing the log to an exponential. You start with the base, b, to the y equals x. That's how you change from a logarithm to an exponential. If you're given the exponential, you do basically the same thing, but it's going to look different. You start at the base, you go across the equal sign, and then back. They're both circular. Okay, so here, if we're changing to the logarithm, it would be log, remember, start at the base, log base b of x equals y. Okay, these were all the same. You can change the log to an exponent or the exponent to a log, which means if you have an equation, we're going to look at what's below that line right now. If you have an equation that has An exponent is what you're solving for. You can solve for that by putting it in log form. Well, how's that help? Well, you're going to be shown how to find logarithms on your calculator. It's very easy. You have a log button, and you have thank you. I know I just did that with my hand. It's now not muted. Hopefully you didn't miss too much. This is on your calculator. You have a natural log and a logarithm. They're on the left-hand column. I don't have my calculator out yet, but I'm sure you can find them. That says log. The log button means log base 10. Our numbering system is base 10. And a lot of what we do is base 10. So if you're using base 10, you don't have to put that in your calculator. You just write log. On your papers, you also do not need to include the base 10. You can just write it as log, and everyone knows that you're talking about base 10. If you're talking about anything other than base 10, you need to have a base, which is written as a subscript. It's below the line. But if you just write log, we understand that that means log base 10. Natural log is log base E. Now you haven't probably done much with E. In fact, this might be one of the first times you have. E is a number, and that's a terrible E. I don't like that. Right. E. It is similar to pi in that it is irrational. It is non-ending and non-repeating. So it's about 2.7. I think it might be 2. I think it's 2.76 something. And I think, again, because I usually don't write out what it's equal to, I just use E. I think it might round to 2.77. But again, this is non-ending and non-repeating, so it just keeps going on. So instead of writing that big long number, we just use E. And all you need to know is that basically it's a different base. And for many of you, if you have not used natural logs very often in your work, it might help you to start by using log base E. ln means exactly the same thing. Okay, but sometimes it's helpful when you're first beginning this to write it out as log base E. Now your instructor's probably going to use the ln, and on your calculator it's labeled as an ln. Okay. I showed you what the exponential function looks like when we graph it. And I think I just hit the erase button by mistake with my hand. Okay, let's try that again. There's 1, 0. I'm sorry, 0, 1. I turned the graph. Whoops, wrong one. I turned the tablet so I could do it, and I did it wrong. So that's about what your exponential graph looks like. The logarithmic graph is the inverse. And if you remember, an inverse graph is flipped over the line x equals y. And the x's and y's are flipped, which means if the exponential graph goes through 0, 1, then the logarithm graph has to go through 1, 0. And it's going to look like this. Now, on your calculator, it may look like it ends. In fact, depending on what your screen, your window is set at, sometimes it looks like it ends there at 1, 0. It does not. It has the y-axis as an asymptote, where the exponential function had the x-axis as its asymptote. So again, it gets very, very close to the y-axis, but it doesn't touch it and it doesn't cross it. So this is the graph of log base b of x. And the line was the graph of b to the x. Well, it just didn't want to write right, but that says b to the x. Okay, and we've covered quite a bit of some different things today. I think we're going to stop about there. I'm not going to put logarithms and exponentials on this week's quiz. I think what I might do is maybe include 2 functions that you have to find the zeros of, which would be using the rational roots with a p over q to limit it. Maybe I might just give you 1. Have you tell me how many positive and how many negative solutions there are. Tell me what possible rational roots are, and then find them using synthetic division and factoring. Because if I gave you one of those problems and had you do all of those things, it would probably be a good 10-point quiz. I have graded your quizzes from last week. I haven't recorded them yet, but I think I already said you did very well on it. So I will see all of you on Wednesday. Take care.